Hello dear students. So in this question we have a block is moving on an inclined plane making an angle 45 degree with the horizontal, and the coefficient of friction is given to be mu. The force required to push it up the inclined plane is 3 times the force required to just prevent it from sliding down. If we define n is equal to 10 mu, you need to find the value of n. So the angle of inclination is given to be 45 and this surface is rough with coefficient of friction given to be mu. Now if I place a block on this inclined plane, so this block has mass m. Now if I write down the forces, or initially if I draw the free body diagram for this block, so along the plane we have the component of mg, which is mg sine 45. Perpendicular to the plane we have mg cos 45, and from the surface we have the normal reaction, that is n. So let us see the first case. In the first case, the force required to just push the body up. So this will be the direction of the force. And say this force is F1, right? So the block will have the tendency to move up. Tendency of motion will be upwards because of this force. Therefore, the friction will act in the opposite direction. And this friction will be the maximum static friction, because the condition is given that the force required to just push up the body. So just is mentioned. So this will be the limiting situation. So from here I can write this force value is equal to F1 is equal to mg sine 45 plus this limiting friction, right, by balancing the forces along the plane of the incline. Now what is FL? FL is equal to mu times n, that is mu times the normal reaction. Therefore F1 is equal to mg sine 45 plus mu, and what is the value of n? If you balance the forces perpendicular to the plane of the incline, we get the value of normal reaction is equal to mg cos 45. So from here we get mu into mg cos 45. So let this be equation 1. Now let us see the second case. Again we take the same inclined plane, keep the same mass on this rough surface. Right, so same forces will be acting on the block, that is mg sine 45, mg cos 45, normal reaction from the surface, so in this situation it is given you need to prevent the sliding. So sliding obviously will occur down the incline, so there will be motion tendency down the incline. Therefore friction will act upwards. And again this friction, just to prevent sliding, this friction has to be static friction or maximum value of the static friction, which is FL. Say. And you are applying force in the opposite direction to prevent it from sliding. Say this force has magnitude F2. So by balancing the force along the plane of the incline, I can write F2 plus FL is equal to mg sine 45. So the value of F2 is equal to mg sine 45 minus FL, and the value of FL is again mu times normal, and the value of normal is equal to mg cos 45. So mu into mg cos 45. So let this be equation 2. Now from the question it is given f1 is 3 times of f2. So I can write f1 is equal to 3 times f2 according to the question. So simply put the value mg sin 45 plus mu mg cos 45 is equal to 3 times mg sin 45 minus mu mg cos 45. Now you can cancel out the following terms, that is mg. So you can write this as 1 by root 2, that is the value of sin 45, plus mu into 1 by root 2, the value of cos 45, is equal to 3 into sin 45 again, which is 1 by root 2 minus mu by root 2. Simplifying, we have 1 by root 2 plus mu by root 2 is equal to 3 by root 2 minus 3 mu by root 2. Further simplifying, we have before that we can cancel out all root 2 terms. So further simplifying, we can write 4 mu is equal to 2. Therefore the value of mu is equal to 1 by 2, and we need to find the value of 10 mu, which they have given to be n. So this n is not normal reaction, this n is just a number which is equal to 10 mu, and mu we have found. So 10 into 1 by 2, which is equal to 5. So this will be our required answer. Okay, thank you.